Welcome everyone to our PyLadies Lighting Talks event. It says with Women Who Code because they were nice and partnered and put it on their meetup page too. So thanks for that. And I want to thank Yelp for having us here. Can we give them a hand, please? Yay, Yelp. Okay. I usually forget to introduce myself when I do these. So I'm Michelle Glauser. I'm the one sending all the emails and everything. And I'm the head leader of PyLadies SF. And I want to give a small pitch. We always need more helpers for things, especially people who are willing to organize or show up early and check in. So if you would like to help and have some spare time, well, actually no one has spare time. If you are willing to dedicate some of your time to helping PyLadies, that would be great. Please let me know. So tonight is an event for people who identify as women in a way significant to them. And we have gender inclusive bathrooms in the back. So if anyone needs to use those, they are towards the entrance. What if you can't read your own handwriting? I don't know what that says. Okay, great. So we will be hearing talks from 18 different people, unless some of them did not show up, which means we have to be very, very strict about the time. And what we will be doing is someone's going to be sitting right here with a timer counting down. And when the timer goes off, we're going to start clapping. And we will thank you profusely. And then there will be time for one very short question while we set up the next one. Okay? There will also be a break in the middle after the first 9 because it gets tiring listening to talk after talk after talk. Even though they're really awesome talks, I'm so excited. Okay. So, does anyone have any questions before we get started? Christina. Yes, but I cannot show them to you because we're showing other things. So I will announce each person and then say who's on deck. Okay? Yes. Yes, there is a clicker thing that I will hand to you. And what's your name? You're Lisa. Okay, great. I just wanted to make sure. Great. Okay. Any other questions? It is on some of the screens over there. It's Yelp Pub, I think. Welcome to the party, all lowercase. Oh, it's right there. Yeah. Great. Nice. He's on the ball back there. Okay. Great. Okay. Any other questions? Okay. So our first speaker is Schwinn. She works here at Yelp. And she is going to be talking about how likely would you give a 5-star review on Yelp. Let me just pull this up. And the person speaking right after that, whoops, I have to look at the list, sorry, is Lana Lee about practicing code and APIs.
Thank you. Paper. Hi everyone. To skip some time. So my name's Xuan. Sorry. And I'm a software engineer at Yelp. Today the topic, sorry about my voice. All right, official. Today I would like to talk to you about how likely would you give a 5-star review on Yelp. I will walk you through an example and get our hands dirty with scikit-learn. Oops. All right, so you guys are at Yelp. Yelp is a website and mobile app that connects people with great local businesses. At Q1 this year, we have over 90 million mobile users, over 100 million reviews, over 70% of the searches are on mobile app and mobile site, and Yelp is present in 32 countries. Before we start, I would like to do a quick show of hands. So how many of you have heard of scikit-learn? Awesome, thank you. How many of you have played with scikit-learn? Awesome, thank you. So these are the tools that I'll be covering today. All these are Python related and they're all open source. Let's go over them really quick. Pandas is a data analysis tool. Seaborn is a visualization tool built on top of Matplotlib. And scikit-learn is a data analysis and data modeling library that you can use. Last but not least, Jupyter Notebook, also known as IPython Notebook, is a web interactive tool where you can easily write code and execute the code and look at the results and share with the other developers. Since we're at Yelp today, so I would like to get your hands dirty with a case study on Yelp's public data set. What's Yelp's public data set? You can get access to it with this link. Yelp's public data set are Yelp data. We publish for data in 10 cities across 4 countries. And these are very rich data. The data include normalized user data, review data, business data, as well as user check-in, user photos. So the use case I would like to walk you through today is, given users past reviews on Yelp, when the user writes a review for a business she hasn't reviewed before, how likely would it be a 5-star review? That's our case study. So when I play with and think about this problem, I actually play with a Jupyter Notebook, IPython Notebook. So I've put everything I have, including this slide and my code and the data and the Jupyter Notebook, into this GitHub page, and the link will be available at the end as well. Let's get started. So I've mentioned, similar to most, other data talk, the first step of everything is you have to load the data. Here, I mostly look at 3 types of data: the business data, the user data, and the review data. For each data set, I put them into a separate data frame. Usually before I dig into modeling the data, I would like to visualize the data. This is not from this public data set, but this is the source's Yelp's press page. So on that press page, it says 44% of Yelp's reviews are 5-star reviews. I'm usually a more, paranoid person, and I usually don't trust any number that's directly published on the press site. No offense, but so I look at our data. I use these 3 lines. I use Seaborn and use this 1 line to plot the distribution of the star rating of the reviews from that public data set. It looks like, the x-axis are 1, 2, 3, 4, 5. So we definitely see more 4 and 5-star reviews compared to 1, 2, 3-star reviews. I also, this is another trial. I try to plot those data by year. So the x-axis are from the year 2004 to the year 2015, because I was using last year's data set. And you can see that Yelp has a pretty healthy growth for the number of reviews. And in the latter years, we definitely see more shift towards the 5-star reviews. All right, now let's do the real stuff. Before we can model the data, we need to visualize the data. So this step is probably the most time consuming because we are looking at the real data here. So I had to do a lot of heavy lifting, including converting the date stream into a date delta, like how many days in between. For example, for the business age column. Also, I have to convert some strings to categorical features. One example is the noise level. So on the data set, for business, it has noise level of quiet, loud, very loud. I need to convert those strings into categorical features. And I also drop some unused features for this modeling. After that, we got 3 tables: the user table, the review table, and the business table. But we would like all the features into 1 big table. In Pandas, it's actually quite easy. I use the join command. So if I do review df.join, it will join the review data frame with the user data frame. And after that, I join the joined data frame with yet another data frame. At the end, I got everything together. Awesome. Now, similar to most of the other machine learning tasks, we need to identify the data and the target. So data X stands for all the features we gather in this case, are features from the business, the user, and the review tables. And target Y usually stands for what we would like to predict. So in this case, target Y is whether the review is a 5-star review or not. So it's a binary decision, yes or no, true or false. This is essentially a classification problem. In order to better later evaluate our model, I need to split the data into a training set and a testing set. In scikit-learn, this is easy by calling this train test split function. And you can see in our training set, we have a little over 1.66 million samples. Each sample have 99 features. In our testing set, we have about a third number of the samples. Next, the modeling. The algorithm I chose here is called logistic regression. Logistic regression estimates the probability of a binary decision. In this case, we're trying to estimate the probability of a review being a 5-star. So because this is logistic regression, so I had to call some function to standardize the features. Let's go over that really quick. And finally, I also call one function to build the model and call another function to run a 5-fold cross-validation on the model. And I write a helper function to print out the cross-validation score. It looks like just by doing some very basic modeling, we got a model that has a 75% of accuracy. What does that actually mean? Because this is a classification problem, so we can plot the answers, plot the labels of true label and predicted label into such a matrix. We call a confusion matrix. You guys have probably heard of false positive and false negative. So this model have false positive about 16% and false negative about 36%. This is just a first trial of the models. Okay, now is the interesting part because remember we had at the beginning we have the question: given the random user and the random business, how likely would that user give that business a 5-star review, right? So I randomly pick a user. This user, I'm sorry, it's a little bit more. Yeah, he or she, I don't know, has written a five reviews before, and this random business is called Pastino Arcadia. It's a wine bar in Phoenix. I ran it through our model. It looks like our model says, yes, this user will give this business a positive review. Another case is another user who has written 10 reviews, and this is a little bit shadier business on Yelp. It's a public transportation, and it looks like our model verdicts that the answer is no. It's not going to be a 5-star review for this user on this business. I'm glad you laughed. I'm like, yeah. All right. If there are 3 things I would like to you to get away with this lengthy talk, is first, writing Python on Jupyter Notebook to do data analysis is actually quite easy. Secondly, scikit-learn has provided you with a lot of great tools that you can basically build models like baking a piece of cake. I hope that's easy for you guys. And last but not least, Yelp's public data set is very rich. You guys should definitely check it out. That's all I have. I'm glad I'm in time, and these are the links and my personal contact. And I guess I'm allowed to answer one question. Is there a question?
Lana, can you come up, please? Question, Candida?
That's a very good question for the recording. I'm repeating the question. The question was, can anyone get her or his own personal data from the public data set? The answer is no, because all the data are normalized. The reason that we're giving out those data is for academia usage. We don't want you to target any user. So the answer is no. So I can't tell which user gave which business a bad review, if that's what you're asking. But I think you know what you wrote, like what review you wrote for what business, right, on your own Yelp site. I hope you do. Thank you.
Lena, you're next. Okay. Lana's next, talking about APIs.
I'm going to stand behind my podium here because I have super high-tech notes. Right. Well, hello, everyone. My name is Lana Lee. I'm a software developer for a small consultancy here in San Francisco. It was my last day at my company today, so I was at one. My talk is going to be it's going to be non-technical. It's going to be about working on side projects. And it's mostly inspired by my struggles with trying to make time to work on side projects when I know it's important and I'm trying to work like 1.5 times. So why am I doing a side project at all? I took on a side project to keep current with today's technologies. For my day job, I work with ancient and/or niche technologies, including Java on the enterprise level, and a very special flavor of it too, and JScript.net. And to those who hopefully don't know about JScript.net JScript is basically Microsoft's implementation of ECMAScript, and .NET is a framework for Windows-based applications. So that was my life in the last 1.5 years. I had to relocate to the 1990s. Great time to be in, but not super great for software when you're working with it today. So I decided that one day I didn't want to be pigeonholed in the technologies I use for work. And there are a lot of tools out there that I wanted to familiarize myself with. The only way I was going to get there was to learn and practice them. So a good friend and I decided on a timed project where I would practice something modern, APIs. The idea of the project was to implement one API a day for 30 days. By day 30, I should be comfortable with reading documentation, making requests, and parsing responses. And in case anyone isn't familiar with what the API is, it's basically a program that when it gets data in a proper way, it returns different data. That's all it is. So each day I was to not worry about the front end. My only goal was to give the user a way to enter some data and a way to see the response. So I'm not even going to show my implementation, but it's very simple. There's nothing in the front end, just a button and words in the button. Super I'm embarrassed, so I'm not even going to show it. So I was to implement a variety of APIs found in the wild, some client-side only auth, some server-side auth, and hopefully some in a different language. I only know one language, so I don't know, but some in a different language. Why 30 days? I wanted to practice consistency because consistency, theoretically, can lead to habit or should lead to habit. And if you're in the phase of your life where you have discretionary time and you want to get better at coding, a good way to do that a good habit to form is to code every day. And of course, we all know the ABCs of coding. Always be coding. And the faster you can get fundamentals down to the extent that they're almost second nature, the faster you can build more advanced skills. So what actually happened? Failure. I failed pretty horribly at the consistency part. This is a picture of my GitHub. There's nothing in the last year because I just haven't had time to do anything. This is actually from a GitHub from earlier today. And there is nothing from when I really wanted to put something in there. So it's a failure, but I'm being very public about it because I think that's good for me. What happened was I implemented my first API twice. So they both became my 0th API and I need to start over again. But I took some good lessons from this. What I learned was, my first lesson was, it takes a lot more discipline than I thought to be consistent. I thought it would come to me naturally because I wanted so much to stay current with my skills. But I'll always find an excuse when I don't feel like it, and there's no one cracking the whip on me. And you have to make time to do it because thinking that a project is important isn't enough to make time appear magically. Number 2, don't be so hard on yourself. If you don't know if you haven't touched a language or a technology in a while, it's okay to start slowly. As J.K. Rowling said, achievable goals is the first step to self-improvement. So break into small pieces and take it one step at a time. Don't get discouraged. And then lastly, pick something that genuinely interests you. Fortunately, with APIs, there are enough of them out there that you can find something that really sparks your curiosity. So what's next for me? I'm going to try to implement 30 APIs in 30 days again. But when I wrote this talk, I was gainfully employed, and as of about half an hour ago, I wasn't. So I have 2 whole weeks in which I have 100% of my time all to myself. So I have no excuses to get everything done this time around. So if you ever plan to do a side project to learn, which is a great idea, do it. And if you find it hard to stay focused, you're not alone. Look at me. It's hard. Don't give up. Good luck. Thank you.
Okay, so one question for Lana.
All right, thank you. My name is Lena Gunn, and I'm a software engineer at a small nonprofit called Hypothesis. We're an open source software project, and we work from 4 different countries and 3 different time zones, which makes everything harder, as you can imagine. So one thing that we've noticed is that a lot of us are working remotely nowadays, and we've just been thrown into it without any instructions of what to do or how anything should change to make work more effectively. So we've been starting to write some of these things down. I'm just going to present some of my favorites, but you can go to my GitHub, and I have a full list. It's a very long list of stuff, and you can contribute to it. Please do. The first thing that I'm going to say is about schedule and time management. So the first surprise when you start working remotely is that you have an ocean of time. And depending on, every day looks like an ocean of time. And depending on your personality, this may be really overwhelming. There's many adjustments you have to make. For example, I get up at 6:30 a.m. every day, and sometimes things are on fire. So it happens. And I think the most important lesson we've learned is that you own your own time, and no one can tell you when you should be available or not. Especially, no one's paying attention to your schedule. You have to set yourself away on Slack. You have to reject and accept meetings. You get to decide when it's okay to contact you. And learning that and starting to do that, it's a little challenging. The other thing is communication, and this is my lovely team, everybody looking very serious on a conference call. You will notice that your communication style is going to need a lot of adjustments. Polite is not enough anymore. You have to be very direct. You have to learn how to ask effective questions and ask early, no matter how bad you feel that you're interrupting someone. Interrupting is okay. It's up to the other person to say, I can't do that right now because I own my own time. You have to learn not to read too much into things, because sometimes you will miss an email or someone will not respond to your message. And it's likely not that they're mad at you, it's just that things happen and communication breaks down. And finally, there's a ton of writing. There's so much writing. I know you want to write code, but it's all writing all the time, or reading. And on that note, you have to learn how to make and communicate decisions. So typically you're on Slack and you're throwing ideas around. You think, oh, this would be so great. But from that conversation, someone understood that you were going to do it, and someone understood that it's never going to happen, but it would be nice. So decisions need to be communicated as decisions. We have a special type of document, an ADR, for technical decisions. And we have been experimenting with ways of giving and receiving feedback. One thing that we've learned is we have to be super specific about the feedback we want. Do you want help debugging something? Do you want notes on your document? Do you want someone to actually write this part of the code because you don't know how to? What do you want? That's important to me. The other thing is we have a whole set of practices around health, family, and logistics. And one of them is find a good setup and something that works for you, either at home or somewhere else. Coffee shops are terrible. Don't work from coffee shops. They're super loud. No one can hear you. But mostly, I think the one that I like the most here is do not apologize for taking care of yourself and others. I find a lot of people apologizing for taking vacations or blocking time off their calendars to take care of their families or their babies or walk their dogs. And this is something that we encourage each other to do. Just block the time of your calendar and take care of yourself. And learn how to recognize burnout and how to avoid it. Because we're not in the same room, we will not know if you're sad or if you're burning out or if you're going crazy. And finally, there's a lot of stuff you need to learn how to do around leadership and group dynamics. One thing I tell everyone is learn to facilitate meetings because you're gonna have to, even if they're not your meetings. And the other one is you have to assume the best. You have to assume that everyone on your team is doing the best they can with a set of variables that you don't know about and that you cannot possibly understand. So you just have to believe and assume that they're doing well. So, one question, I guess. One question. We're pushing that on Read the Docs. We're just posting it as documentation.
Okay, Monique is next. She'll be talking about Arduino programming. Woohoo! And after Monique is Elisa. Elisa, please be ready.
Hi, everybody. My name is Monique Blake, and when I came in, I was told the pressure is on. Yeah, real stressful. So I am kind of an interesting individual because I combine hardware and software together. And I also did tech education. And a little fun fact about me, even though I'm an engineer and went to school for engineering, I actually have an art installation or had an art installation at Bryant Park, which is a block away from Times Square. Anyway, so this is about demystifying Arduino programming, a breakdown of microcontroller coding structure. I try not to go too much in depth with these things because, you know, they're supposed to be fast, but before I go into Arduino, what is a microcontroller? A microcontroller is a miniature, inexpensive computer. And unlike a computer, it's dedicated to only one task, and it's typically lower in cost. Like you can get one for like a couple of cents. It's usually used for sensing input from the real world and controlling devices based on that input. That is very, very, very important to remember because that's like the premise of any microcontroller that you use. Microcontrollers combine hardware and software and also analog electronics together. Now, about input and output. So microcontrollers contain pins for input and output. What are pins? See those legs on that? Right there, those are your pins. So input and output is these like a microphone or a push button or an LED or like audio or data coming out. So what is an Arduino? It's a learning platform. It actually uses an Atmel microcontroller, and they designed it so that you could rapidly prototype. So typically it takes very long to do things like the professional standard way in C. This goes well for iterating very quickly. I had a client who changed their mind every 5 seconds. Arduino was great for that. So Arduino pins. So pins on the leg of the microcontroller on the Arduino are as diagrammed in green. The one that you're seeing, the not so big one, that is also an Arduino someone hacked together. So you can see how they're similar. That nice little block that you see right here, that is essentially what you're looking at, the Atmel chip. So an example of the pins and how they correlate is in this really simple example of blinking LED. So the one on the yellow is the pin 13, and that's how you access pin 13 on that leg for this thing right here. And then ground is a ground pin that you see in black, and then you hook up your LED and your resistor together on a breadboard. So to go into the code, you have an infinite while loop. I didn't realize this was so blurry. I apologize. The main premise of any microcontroller programming that you do, whether it's an Atmel chip or a PIC or an Arduino, you have a setup which it's only a run once in your program, and then an indefinite while loop that ends once you like turn off your microcontroller or like run out of battery or something. So to further that example on how that setup and infinite loop thing works is kind of like this. So back to your blinking LED example, pin mode 13 says hit pin 13. And then for your output, since we remember that an LED acts as an output, we say pin 13 is our output. Then the indefinite while loop says, can you write to pin 13 a high? High would be 1. No, 1 is on, binary. And then you delay for a second. That's in milliseconds. That's why it says 1,000. Then you write again on pin 13 as low. And then you delay again, which causes it to blink on and off, Christmas tree style. And if you're interested in resources, what you can do is go to these sites like Hack and Mod or Instructables or Adafruit.com, the blog, or Hackaday or SparkFun, which I'm totally plugging because I also have a contract with SparkFun that I didn't do yet, that imposter syndrome. So yeah, the end. And if you're interested in contacting me, here's all my information. My Twitter and LinkedIn are the same. I'm looking for work right now, and if you can't provide that, I have a really cool repository. Everybody thinks it's very cool and wants me to do everything, but I don't think I can do it alone. It is finding the safest possible route through Google Maps. Right now I have it for New York. So if you can help me out because other people want to contribute on like different projects, please let me know.
Okay, is there a question? Oh, that was close. Who did you see first, Monique?
That's a great question. Actually, the coolest thing is my last contract that I had. I was working with Former Intelligence, and he wanted to build a haptic feedback system, which wraps around your arm, and you can feel tactile feedback. I think that's actually really cool. So if you were on a battlefield, you know how everyone's doing because you have some sort of response for like the 20 people around you.
Okay, so Elisa is going to talk about a writer's theory of everything, and then Lisa Ballard will be next to talk about tracking space probes with Python.
Okay. Okay, my name's Elisa, and I'm actually a technical writer. I jumped right into technical writing, doing API documentation after writing grant proposals for several years. And I had no idea I wasn't supposed to be able to do this, right? So I was going right into really technical stuff. After a couple weeks when I, had my first draft of an introduction, people were really excited, and I was like, well, what? This is just my job. And because of their surprise, I started realizing I needed to begin explaining how I was able to do this. So that's why I have here hard to understand but worthwhile, advanced, and rather esoteric tools to use for writing about technology in ways that people will actually understand. Okay, so the reason I've done it that way is, as I realized, I had an advantage over a lot of other people in that I grew up around the books of my grandmother, and she had been in the inner circle around Carl Jung. So I learned how to read at the same time I was learning how to talk. And because I loved picture books, I would go into the library and I'd pull the biggest picture book off the shelf that I could find, which was Carl Jung's Man and His Symbols. And so I grew up and I kind of internalized some of these these ideas. This symbol here is called an Ouroboros. Who's seen this before? It's a diagram of the universe. So if you change the morphology of the Ouroboros, you have a yin yang, because the snake is swallowing its tail. So morphologically, the yin yang could be seen as similar. Now the yin yang comes from a diagram of the heavens, or whatever you want to call the night sky, and of the equinoxes and the solstice. And that's kind of interesting. There are lots of different ways, though, that you can see the yin yang. You can see the yin yang as a sine wave. And you can also see the yin yang as Taoist philosophy in terms of duality plus emptiness. And you can get very spiritual with some of this stuff. So it's kind of fun to work with this, but where it applies to technical writing is that we are actually hardwired to learn using story. So no matter what, even if you're doing API documentation, you have to kind of find the story. And finding the story can be difficult. If it was easy to find compelling stories that are appealing to wide audiences, we would all be writing screenplays, right? But we wouldn't be able to get 6 to 7 figures for writing those screenplays, okay? Now, the Hollywood formula actually was Hollywood rediscovering things that other people had talked about, Joseph Campbell being one, that there is sort of a story that emerges in every culture and in lots of situations in order for us to explain things. And it follows a certain pattern. It has something to do with how our brains are wired. I'm repeating myself, but that's really important. Now, most of the time when we learn code, we're journeying into the unknown, and it can be scary, and we have resistance. It helps to understand certain things. One thing is, if you look at layers of symbolism, this can look really esoteric, but it's actually useful. We want to get to the point where we're operating at a state of being, where certain things become habit because they're internalized. So think about driving your car. You get in the car, you go towards the highway, and all of a sudden, you find yourself on the way to work when you actually meant to make a turn to get to the grocery store. You've been in the state of being in terms of operating your car. Now, that might not agree with the way some people see it, but the other thing that's important in this, and you can look at this in lots of ways, when we look at the application layer in terms of networking, that is actually the highest layer of abstraction in terms of programming, but it is actually what people think of almost as a physical layer in terms of everyday use. So your end user thinks of that as something that's almost solid for them. All right. So there are other tools that writers use, and you basically have to be able to make your thinking very flexible. That's why I have this picture from Inception here. All right, so lots of other stuff.
Can you answer one question? All right. Who has a question? There's one. Okay.
I'm on LinkedIn. I don't know if you'll be able to access. I have an email on all the slides. So if you have the link to the slides, I can give you a card. You can search for me on SlideShare. Sorry.
Thank you. Okay, so Lisa is next, talking about space probes, and then Liz Lee is on deck for what no one is saying about online harassment.
Hello. So my friend and I wanted to make a website. This is a side project, and we're space fans. And so we were looking around the internet and found that there was really no place where you could go to see what space probes are active in space right now from any different country. NASA sort of has its own websites, and the European Space Agency has its own, but there was really no like all-encompassing website. So we made this website, and we used Jekyll. It's a static site generator, so we made this static site, and you can click those space probes and get information about each probe. But then when we did that, we were kind of looking at ways to improve it, and we really wanted some data. Like we wanted some like recent data, like something that you could go and like check on your latest space probe or your space probes that you wanted to look at. And so we went looking around the internet for where could we get like real-time space probe data. And we looked at this website. So this website is DSN Now. It stands for Deep Space Network. The Deep Space Network is a worldwide network of radio dishes that are constantly communicating with deep space probes. And they have this awesome website called DSN Now, where you can go and see real time what probes are talking to Earth right now. And so we sort of wanted to like check this out and maybe reverse engineer it a little. And so we used our Firefox web tools, and this is a tool called Live HTTP Headers. And it shows you, if you open it while a web page is open, it'll show you all the AJAX calls that a page is making. And so if you open that up on this website, you'll see that it keeps pinging this URL every few seconds or so. And so we opened that URL to see what it was doing, and we got this like giant, massive mess of XML, which is scary and scares me and scares cats. So we didn't quite know what to do with this, so enter Python. And so we aimed some Python libraries at it and basically turned it into JSON so that we could actually read it. And for this, we used a Python library, xml.dom.minidom, which just makes it easier to traverse XML documents. And that's in the standard library. And then the other thing we used was XML2Dict, which is a tool that will turn an XML object into a Python dictionary. So then what we ended up with was sort of a mirror of the feed so that we could look at it. And when you look closer at it, you can see that it's telling you space probe names. So that name Rose right there stands for Rosetta, and DSN Now has a very helpful page that will translate all these codes for you. And then that range number is actually a distance. In aerospace, range means distance to a thing, kind of like a gun range or something, I don't know. But so that's actually the distance to Earth. And what happens is the probe is pinging Earth, and it's saying, this is my distance to you right now. And so that was a bit of data that we thought was an interesting thing to include in our website. And so what we did was we took that JSON and we sort of just remixed it because we wanted it by probe. We wanted to say for each probe, what is the range or what is the distance? And so that was just sort of a little bit of remixing. And then we wrapped it in a very simple Flask app and put it on Heroku, and then used Heroku Scheduler to hit the DSN XML feed every 10 minutes. And then we save the data to just a Redis object. Redis is a JSON sort of database. It's just a super easy way to just save something in JSON on Heroku. And so we did that, and we let it scrape for a while. And then pretty soon we had a database of these constantly updating space probe distances. So this is online. You can go to this JSON feed. That's all it does is serve JSON. And then when our site loads, which is on a completely different server, when you load our site, it does an AJAX call to that JSON feed, gets all the distances, decides which probes to put on top, because these are ordered by distance. And so that's what's happening when you load the page. And there's all these distances showing, and that's what it's doing. It's doing a remote call. So that's it.
Hello? Okay, great. So this is Liz. She'll be talking about online harassment. On deck, we have Rachel Thomas talking about deep learning.
Hi, everyone. So I will be talking about online harassment, which means just a trigger warning for people. If this is a sensitive topic, I won't be offended if you get up and leave. That's totally fine. It's suggested. So, show of hands. Can anyone remember the last time they were really angry? Like really ticked off? Okay. And show of hands, can anyone remember when they felt very helpless, very out of control? So, I know, random questions, but my name is Elizabeth Lee, and I have a confession. If you look me up online, if you can find me among the sea of Liz Lees out there, you will find that I was the proud captain of my high school basketball team, that I graduated with honors from the Wharton School of Business at UPenn, and that I worked at Morgan Stanley for 6 years investing in VCs. But what only some of my friends and none of my personal contacts know is that I had to deal with both in-person and online harassment for 7 years. That includes stalking, threats of violence, hacking, impersonation, and this kind of meant my door got busted down, that I considered getting a restraining order, that I got phone calls at my work, etc. And the question that most people have is, what the heck did you do to attract this negative attention? And to be honest, the threats came first anonymously, and then I found out that it was 2 of my ex-boyfriends at different times. Why am I talking about this, or why am I being public about it? Because, unfortunately, the statistics are now showing that people in this room could have had a similar experience. So, there's a very often cited Pew study that 4 out of 10 people in America have experienced some form of online harassment, and 7 out of 10 have witnessed it. But the stats are much more egregious for women. So this actually is a study done by Norton for women in Australia, but 76% of women under 30 have experienced online harassment. So what are we talking about here? So it really ranges. It could be individual threats, doxing, swatting, stalking, etc. There's a great kind of wheel that Soraya Chomali, who's a great writer, she's kind of created that wheel to kind of give a framework for what's going on. But I think the sort of message that I want to convey is that if you have experienced this, you are not alone. You are not crazy for feeling out of control or for feeling helpless, because the way online harassment is defined by the main researcher in the space, Danielle Citron, is that it's a persistent course of action, a course of conduct that's targeted at a specific person. But more importantly, it's designed to cause substantial emotional distress and fear of physical harm. I think it's easy for people who are very strong-willed and very independent for you to possibly feel weak, or like maybe you're a coward or you should be strong enough. But this is just to say that it's designed that way. A lot of harassment is targeted at people's identity or what they care about most, and sometimes it's their work. What is no one talking about? I had to come up with a fancy title, so I tried to spin it to make it sound really interesting, but really it's money. No one talks about the money associated with online harassment. And if my years at Morgan Stanley taught me anything, follow the money and you'll see where the incentives lie. So Yasmin Green, who works at Google, wrote about the big business of online abuse, that there are people who profit off of this. Social media platforms, there's a revenue and a cost for user engagement. So any time you hear someone, a representative of the company, saying, well, we it's very hard to deal with this problem at scale. Just remember that there is a cost to running the platform, and user trust and safety can just be considered another necessary cost. But I don't want to get into that. I want to talk about users. So just to kind of share my journey. Oh, I'm done. Sorry, guys. Thanks.
All right, I'm going to ask the question, what is your journey in 30 seconds? Rachel, do you want to come up?
Well, so what I'm doing now is I started a nonprofit called Online SOS. We provide crisis coaching to people when they're experiencing or in recovery from harassment, and we give them a referral to their needed services, whether it's legal, safe housing, etc., and a donation to help pay for those services, because money is often the reason people don't get or seek the help they need. So I'm Liz at onlinesosnetwork.org. Please come find me later, and thank you.
Okay, Rachel's going to talk about deep learning, and then Christina's next with pass-fail testing code from a teacher's perspective.
Oh. Cool. All right, I'm Rachel Thomas. I'm going to be talking about deep learning. It's more than a fad. I'm on Twitter at math_Rachel, and I'll tweet a link to my slide deck later. So a question I hear a lot is, are artificial intelligence, machine learning, and deep learning all synonyms? Is deep learning just a marketing buzzword? And the answer is no. Deep learning is a very specific class of powerful algorithms. So broadly, artificial intelligence is kind of a broad field. Machine learning is a very interesting and large subfield of that. And then deep learning is just one class of awesome algorithms, also known as multi-layer neural networks. So what can deep learning do? It's better at English and Mandarin speech recognition than most people, which I think is incredible. Gmail has a feature called Smart Reply, where you will kind of parse your email. So someone's emailed you about your vacation plans, and it'll auto-generate several possible responses. So you could say, no plans yet. I just sent them to you, or I'm working on them. And deep learning is coming up with that for you. And this was actually an April Fool's Day joke from Google in 2009 because it seemed so outlandish. And then in 2015, they released it as an actual feature. And then art. So on the left is a picture of some houses next to a canal. In the center is Van Gogh's Starry Night, and on the right is a new piece of artwork generated by deep learning, combining the two. Image captioning. So here, the algorithm is just given the image, and then it's generating text that describes it, which involves it's having to identify what the different components of the picture are and how they fit together, and then generate the text. So the top right picture, the algorithm comes up with construction worker in orange safety vest is working on road. This is the headline from a Wall Street Journal article about using deep learning to diagnose heart conditions. Deep learning is also being used to tell if a tumor is cancerous or not from a CT scan. And then Google's data centers, where they have all their servers, generate a huge amount of heat. And just earlier this summer, Google announced that they are using deep learning to reduce their cooling bill by 40%, which is huge. So kind of all these applications I've mentioned are powered by the same class of algorithms, deep learning. So this is not an exhaustive list, but deep learning is good at reading and generating text, identifying and creating images, recognizing and interpreting speech. And what's really noteworthy about this is that these are all things that are very natural and intuitive for humans to do, so much so that we often don't know how to describe how we know how to do these things. And historically, they've been very, very difficult for computers. So it's very noteworthy that deep learning is excelling in these areas. And so this I wanted to show you because if you do really any sort of machine learning tutorial, not just deep learning, you will probably come across digit recognition. It's kind of the hello world of machine learning. And the problem is people have a wide variety of handwriting. Some of us are very floppy. We might write a little crooked or messy. And computers need to be able to know what digit that corresponds to. So on the left, we've got this slanted crooked 8, and we want a mathematical function that can output the digit 8. That's what this is. And so to the computer, an image is just a matrix of numbers. So here, each pixel corresponds to a single number. In this case, it's 0 for white pixels, 255 for black, and every possible shade of gray in between. And we just need a function going from this matrix on the left to output 8. And deep learning is one possible function for that. Correction. So how can you get started? If this interests you, TensorFlow is a Python library from Google, and they have a super beginner-friendly tutorial. So if you're brand new to machine learning, that's a good place to start. If you want to go further, you'll need to learn or review linear algebra, which is vectors and matrices. Khan Academy is a great resource. I'd say even if you didn't like math when you were younger or thought you were bad at it, you probably just had a bad teacher, and I encourage you to give math a second chance. And then I just wanted to say, personally, I feel so compelled by deep learning that I quit my job to start a research lab focused on it. Thank you. Is there a question? So my thought is I think much more, the question was, what are my thoughts about the singularity and kind of controversy around artificial intelligence? I'm more concerned about job loss. I think it's already happening that computers are replacing jobs, and there's definitely a question of, does our society have the kind of social safety nets to care for people when there just aren't enough jobs to go around? So I'd say that's an issue I'd like to see get more attention.
Oh, thanks. Okay, Christina's going to be speaking about pass-fail, and then up next is Michelle Zaffino with computational journalism and data in the stacks.
Thank you. All right, so I'm Christina, and I recently started my first software engineering job at Slack. And before that, I taught high school math for 5 years. So I think there are a few things that developers can actually learn from teachers, especially when it comes to writing code, but also writing tests for code. So as developers, we write tests to make sure our code works the way we expect it to, and that it continues to work as the code base grows and changes. As teachers, they write tests to make sure that their lessons have worked as expected, and that the students actually learned what they were supposed to, and that they retained that learning. Teachers call this process assessment, and it actually involves writing unit tests. You see, a group of lessons that are organized around a similar topic is called a unit. And the unit test is the evaluation you give at the end of the unit to see how close the students got to the learning goals. So because developers and teachers have unit tests in common, I think there are three teaching strategies that can inspire developers to write better tests. So first, you want to begin with the end in mind. This is actually a best practice in teaching where the teacher, before they even plan the lesson's contents and activities, they need to have a clear idea and understanding of what mastery of that content actually looks like. Then they set a measurable and observable learning goals and design an assessment uniquely tailored to measure and evaluate the student's performance toward those learning goals. So I think this has a lot to do with test-driven development in a way, where you begin with the end in mind by writing tests that will evaluate how the code is supposed to function. Then you write the code and keep improving the code until all the tests pass. And it's an iterative process where you keep making changes until the tests pass, and it's based on what parts of the test pass and fail. So when they do actually all pass, you know you've achieved your goal. Just like if you pass your final exam, you know you're ready to go on to the next course. So that's one point, but beginning with the end in mind doesn't mean that you should save testing for the end. So teachers use a combination of both summative and formative assessment. And summative assessment usually happens at the end of a unit or course, like a final exam or term paper, and it evaluates how well the student did and like work toward the learning goals. These are kind of like the automated tests that we run before we deploy code. Those tests are very important. We don't want them to fail. But if the assessment was at the end of the course, that was the only assessment that was given, the feedback from that test would not actually give the student, help them improve at all. So teachers use formative assessment, which happens more frequently and informally throughout the learning process to check on the student's understanding. And I think that's a lot like the manual testing we do as we write our code. And these really help you catch bugs before it's too late, before it stops you from deploying, whether that's running your code, like rerunning your unit tests regularly, or regularly checking it in a browser or in the terminal to make sure it's working as expected. And finally, teachers strive to give specific and actionable feedback. And this is specifically important in like your error messages, because just throwing an error won't help you pinpoint where the trouble actually lies. So do yourself a favor and include specific actionable feedback in your error messages, including the context of the error with a stack trace, even the correct error type, or even the data that is causing the error, because lots of time that's not what we expect it to look like. So these are 3 things that I hope can inspire you to take a teacher's mindset to writing better tests. But also, software engineering has a lesson for teachers and students, and that is that failure is part of the process. So don't be afraid to fail tests, because our code isn't perfect at first, and we fail tests over and over again, but hopefully we fail them in different ways because we're learning. Thanks.
Question? No question. Okay, oh, Candida, go ahead. Lizzie, could you come up, please?
I started teaching myself how to code like in middle school, so I kind of been doing it on my own for a long time, but I decided to do a coding boot camp at Hackbrad Academy to transition into software engineering, and that really helped fill in the blanks for me and give me a picture of everything involved in software engineering. So yeah, thank you.
Okay, so we have a change of plans. One of the speakers had to leave, so she's gonna speak now. Is she still here? Nope, just kidding, she bailed. Okay, let's do our break now. And after the break, we will be hearing from Imju Byon about Get Started with Electronics. And oh my gosh, there's so many good talks coming up. So we'll have 10 minutes and then we will get started again. So grab some refreshments, use the restroom, talk to one person you don't know. We'll see you in 10 minutes. Great. We are about to get started with the second half, but first I want everyone to raise their hand if they've met someone they didn't know before tonight. Yes. If you didn't raise your hand, there will be time after the talks, and I would encourage you to get to know someone. These are also great networking events, okay? So are you ready? Great. We are going to have a talk on getting started in electronics. Watch this exciting piece of machinery right here. And on deck is Missy, to be talking about how she proved her parents love her the best.
The presentation off. So hi everyone, my name is Imju Byon. I'm a founder for the greensprout.co, where you can find after school program, summer camp program for kids. So doing this website, I met a lot of the camp providers and a lot of the kids program organizers. And I got to know some electronic stuff, and I found that they are not so Okay, so try Safari. About that. So, yeah, they didn't turn out that the electronics doesn't need a lot of the complicated knowledge than you thought. So, here's an example. Get this. And then when I press this Tang here, it lights up. Isn't this cute? Yeah. So electronics isn't actually hard. So like simple electronic this doesn't require great, like PhD degree. So the basic circuit design of this design was just one switch, LED and resistor and battery. There are four components. This one on the back, it is actually a circuit that consists of the 2 LED and 1 battery and not even resistor. But you can still create this amazing little creature using that. The basics of electronics is just this, voltage is the I multiplied by resistance. So the current and resistance together create a voltage. So there are lots of parts that you can use. The resistor is regulating the flow. And the little thing, the 3 legs are actually transistor. The transistor is the base of the computer. Right now we are using a lot. And so you can actually start your electronic project. So on the left side is called snap circuit. This is actually for kids, but I found this is perfect way to get into the electronics because there's a lot of examples. And you don't actually need to program it. So I highly recommend snap circuits to start getting into the electronics. And then when you are more comfortable about it, and start doing the breadboarding. Breadboarding is this actually. So it looks like breadboard. That's why it's called breadboarding. In breadboard, you can hook up electronic parts and you can start building your actually little hardware project. And if you are more advanced, like Monique already talked about this, so you can go into Arduino project. The Arduino is the simple gateway programming for the controlling signals. If you want to change the LED lights or change the volume and things like that, you can you can run some motorized stuff. You can use Arduino. So I created this simple prototype today. Show you that that is using the Arduino, and servo motor. Servo motor works in 180 degree. So it works that it's like, you can simulate your arm movement, robot movement. So I have a 5 here. So I throw the dice. Let's see what this thing. Check out this side, this pie. Okay. Yeah. So it went to 2, right? So you do one more time. There you go. So it is using Arduino, the serial, Pi serial, and the flask, and you can get to electronics easily. Thank you.
A question? Anyone? Candida, go ahead.
The snap circuit. I have kids, and on birthday party we got that as a gift. But when I was researching this one, and it is actually my friend's work, and she's going. Her book is coming out in O'Reilly, so I wanted to know more about it, and I did some search. I feel that is an easy way to get into this. Without doing the Arduino, you can do the Arduino part, but you want to learn some basics about circuitry and get comfortable with the parts. Then Arduino is more easy. Then you can build something more complicated. Okay, thank you.
Okay, so Missy is up next, and I am so excited to hear this talk. And after Missy, we will have Michelle Zaffino.
Hey guys, I'm Melissa, or Missy, and I'm here to talk to you about a side project that I've been working on, how I proved that my parents love me best. A little background for this project is that I have 2 parents and I have 2 sisters. And over the years, we have lived in a lot of different places, and as such, we have built up a lot of digital communication, specifically email. My family is really, really good at emailing. And so about a year ago, I was like, oh, I really want to do something with all of this data. What can I do? So the first step in doing this is getting the data. To do this, I use the Gmail API. It's actually pretty straightforward. You can send a request with the same text that you would type into the search box in your Gmail. So you can literally send the string from me to my family's email addresses. It'll send you back a JSON response with all the messages that fit that. And you can take that information, throw it in a database. You have everything you need to analyze all of your family's emails. So I was like, all right, this is easy. And so I started compiling a list of questions that I wanted to answer, like, when did we first send our email with all 5 of us on it? What's my average response time? What's my average word count? And these seem pretty straightforward to answer, but it ended up becoming much more complicated. For example, your average response time, we're emailing from a ton of different time zones, so you have to switch it all to UTC so you can compare it. Like, okay. What's your average word count? A lot of different information comes with emails. There's quoted text from the previous emails. There's people love adding signatures to their emails, and I don't really care about that. This is actually an example of code. My sister has been living in Europe the past few years, and she has an iPhone, so her signature has been changed to the different languages depending on what she's learning at the time. So I have to make exceptions for each of those sent from my iPhone thing. And so I started cleaning all the data, going through it, and I ended up with a list of functions to answer each of these questions. And And so it's just like really easy. You're just like, oh, I want to answer this. And it's like, okay, I'll just write a function to do that. But then I was like, oh, how do I share this with the rest of my family? This is really funny. By the way, I was doing this all in secret. None of them knew I was doing any of this for like months. And so I was like, all right, I gotta get this up somewhere so they can like see what we've been doing. So Skarkov is born. The secret or the backstory behind Skarkov is a side project to my side project was creating Markov chains for each person in my family. My last name is Skevington, so it's like Skevington Markov chains, Skarkov. Anyway, and so here's a screenshot of this website that I built. It's a dynamic dashboard that will keep track of our email patterns. Our first message was sent in 2007, and since then we've sent over 3,200 emails to each other. This is a like user profile for my sister where you have all of her like stats up there. You can see how many emails she sent over time, how many threads she's initiated over time. You can see her thread participation to make sure everyone's participating. And so as I was building this, I started to see different personalities come up from different family members. And like, for example, my mom is like so enthusiastic when she emails. It's just like off the charts. And so I created this whole page. There are a bunch of other things that I calculated in there. But my favorite discovery as I've been doing this was that I now have quantitative data to support the fact that I'm the favorite daughter, just based on email response times, and they have no way to refute it. So anyway, you can check it out. It's at skarkov.com. Yeah. Yeah, I'm the middle child, so I don't know what that means.
Someone left their phone in the restroom. This is the phone. I saw someone jump. Okay, so Michelle's up next with computational journalism and data in the stacks. Yep, that's the clicker. And after Michelle is Siobhán with data in motion. Ooh.
Thanks, Michelle. I'm Michelle from In the Stacks. I've been working on this project for years now. And can everyone hear me okay? Yeah. I moved to San Francisco to write novels, and I'm working on my 5th one. But I also ended up learning how to write code. So a few years ago, I went to front-end development boot camp, and this was after grad school, where I earned an information science master's. And that was mostly a lot of database work. We actually learned how to write XML. It came up in another talk, so it was like really a lot of metadata and taxonomy. So it sort of like brings it all together, but there's a piece missing, and that is a Python piece, which is why I'm here. I want to explain my new project to you. And if anyone has any interest in working with it, working on it with us, please come find me after. So I'm going to go into a little bit more backstory. I'm a former magazine editor, and I wrote these books. I researched them in grad school. But when I went to traditionally publish them, even though I had a publishing background, it was really prohibitive. They're not publishing a lot of real books anymore. But it's very easy to indie publish, so I ended up indie publishing them. But there's so much information overload now, especially with unknown authors, it's hard to find books. So we came up with this project where librarians are giving the book recommendations, and we're aggregating all of the metadata in a database and running recommendations off of it. And so you can see this is we do have a website up. It's basically, we're gathering using user testers there. We have 350 user testers, and we did demo it in March, but we're looking to integrate more algorithms into the back end. And hold on, I'll go into it more in this. We're actually compiling more data sets now. So the librarian brain is a data set for books. And we're also working on this is jumping on to the next thing we're working on. We're working on a narrative storytelling data set for media to create story bursts. So I used, I wanted to find these problems to solve. So that's where we're building these products. And we were looking for more trusted sources, human curation of data to run through like larger data sets. And right now, we have a team of contractors. This is the technology that we're using. There are 6 to 7 of us, and we crowdfunded a little money. We got like a small business loan from the Tory Burch Foundation. We raised like under 25K. We're currently fundraising, and we're currently hiring. So, and here is actually another project we're working on, which is we're looking to gamify a librarian detective story that we're telling online at librariandetective.com. And we're mapping the locations of the crimes through placing literature, which is this really cool site you guys should check out. And we're also tagging keywords and trying to get users involved in shaping the story. So anyway, I have a real passion for storytelling, and I feel like stories have the power to change lives, whether it's the novels that you're writing or using this database to tell like stories in a narrative way in journalism, and then also writing this detective novel. It's just been an amazing experience, and we're looking for people to collaborate with us. So if you have any interest, come talk to me, and I have stickers. So come get a sticker if you'd like one. So thank you.
You want to answer a question, Michelle? Okay. Siobhán. Oh, you're right there.
Thank you. Hello. Sorry.
Anna Schneider's on deck.
So hello, I'm Siobhán. I'm a data scientist and researcher here in San Francisco. And I had experience recently to sort of step outside of my day-to-day and have an encounter with a designer. And I learned some lessons, and I wanted to share those tonight. So I had the pleasure of working with this designer, Maria Blyes. There was a retreat up in Mendocino put together by Slow Research Lab. They're a Dutch research and curatorial platform. And they brought a bunch of people together to explore Maria's new sculptures. And so we got to play and learn about them. Maria spent the last 40 years looking at emergent patterns in nature and cataloging what she learned in sculptures, foam, fabric, rubber. You see here some of her fashion designs. But for this weekend, we got to play with some of her bamboo sculptures. These are made of these bamboo planks with these rubber joineries, and they are just different geometric shapes, and they're really kinetically alive. So when you start playing with them, they start moving and bending. And a few of us there were so excited to see how many shapes we could make, how much geometry we could make. But Maria really stopped us and encouraged us to think more like a sculptor, to spend time with the material, getting to know the bamboo, getting to know how it works, and seeing if in time perhaps it will show us how it wants to move or how it would like to shape itself. So that was the first key lesson for me of what's it like to have a little pause maybe at the beginning or throughout the process, whether working with data or phenomena, to see what patterns are emerging over and above my questions or my hypotheses from a sort of sculptor perspective. We asked her about her inspiration, and she talked about this man, Paul Schatz, who was a mathematician in Switzerland, who, after his formal studies, he spent some time sculpting. He wanted to get his hands in the material and play with the math he'd been studying. And so he spent time looking at how to develop an optimal fluid mixer that would balance centripetal and centrifugal force through a rotation. And through that exploration, he found this optimal motion. And when he graphed that motion and filled it in, it makes this shape, this oloid, which has some pretty interesting mathematical properties. And I love this story because it reminds me that there might be details in the patterns of our phenomena we can only see through movement or across time. And if we only have a method that takes snapshots, perhaps we'll miss that. And I love that story of the oloid. And this is an example. I know the people that do mechanical engineering in the room can explain this better than I can, but this would be an example of hysteresis where in a coil, when you add magnetism and then demagnetize, and you graph that, it's really important to know what just happened right before the moment that you're in to tell you where you're going. And so this would be definitely something in a dynamical system where we'd see that change over time really matters in terms of what we learn from the system. So I'll be traveling in next month to Amsterdam to work more with Maria and to we're presenting some of her work at the Conference on Complex Systems in Amsterdam, and super excited about that. I think the final takeaway that I got from working with her was it's possible to develop like an experiential proficiency in a subject matter in advance of having discursive knowledge about it. So you can learn about a phenomena, you can learn to move with it, be with it, even before you can mathematically describe it. And that's something that's actually very important to her practice, something that I feel like I can take forward in what I do. And just wanted to end with a little bit of an ask. This book's coming out with O'Reilly sometime, I think, in December. When I was this January. And if anyone's interested, I'm looking to put together a little reading group to go through this. It's on modeling complexity. So if you're interested in complexity science or data viz stuff or design solutions for working with big data, I think this book might have some things to talk about that. And I would love to gather with folks to read through it and maybe code through some of the examples. That's me. That's where you can find me. Please. It's a great question. I wonder that too. The author had developed some. It's based on Python. The sort of the software that he developed. It starts with an A. It's like Andromagen. I'm not sure. But I gather that there's the topics are covered, and then those examples can be explored in that program. But I think even just as a text to read it, it introduces the topics of complexity and how to model. I think so. So we can explore together and see maybe.
Okay, so Anna's going to give the next talk, and then Julie Hollick is next.
Thanks. I'm now very excited about this modeling complexity book, but that is not what I'm talking about. I'm Anna. In my day job, I do Python for clean energy, but that is not what I'm talking about either. I'm talking about something that can get in the way when we're writing code, which is unconscious bias. So none of us want to be racist or sexist, but a lot of us have unconscious biases about different groups anyway. These biases come from negative stereotypes that we've absorbed from our environment. So whether it's from TV or movies, or things we hear on the radio, or things we read in books or on the internet, or friends and family and coworkers and just people we meet. All these different stereotypes get sort of worm their way into our brains and influence how we think and act towards different people in different situations, even if we don't consciously agree with those stereotypes if we think about them. So in terms of thriving in science and tech, these negative stereotypes, so there's supposed to be a box in here that says unconscious bias. So negative stereotypes lead to unconscious bias. And that unconscious bias can lead to barriers to entering STEM. So girls being told that they're bad at math at a young age. It can also lead to barriers to rising in STEM, like people of color being judged more harshly in interviews. And it can lead to reasons for leaving STEM, like harassing or unsupportive environments. And so altogether, these problems loop back around to reinforce those negative stereotypes. So we're calling this the a positive feedback loop of negative stereotypes. And this whole system just means that it's a really hard problem to solve. Whatever. Yep. So in the social science literature, this is all a given. The existence of implicit or unconscious bias is beyond reasonable doubt. But I bet many of you have a coworker who doesn't agree with that statement, or maybe is part of the problem. Maybe you're sometimes part of the problem because we all are. So I started volunteering with a group called the Unconscious Bias Project. So we're a group of science and tech people who are reading the social science literature and developing and spreading evidence-based solutions for just being nicer to each other. So I'm going to talk about examples involving women today, but we also support inclusive environments for other types of underrepresented groups too. So who's heard something like this before? She's really smart, but I wish she wasn't so bossy. Yeah. So what are your options when you hear a statement like this? One is to label the stereotype, maybe with a simple positive comment like, she's not bossy, she's a leader. And so by making a positive comment, this will actually work to weaken the negative stereotype for people around you. So how about this one? I think you'd advance further if your hair were more professional. So in this case, even though the speaker means well, she is acting to reinforce the stereotype that women, especially women of color, it's okay to make them spend time and money and energy on conforming their appearance to their workplace. But if it was an inclusive environment, Latifah wouldn't have to do that extra work. And she doesn't have to do the work of explaining why not either. So one cool trick I like is to flip the question back around on the speaker and say something like, what's unprofessional about my natural hair? And make them do the work of explaining and challenging their own assumptions. One last example, the bias against working mothers is still very real and very documented too. And so maybe this is the 5th time today that Preeti has been asked, oh, what's gonna happen when you start a family? And maybe she's just sick of responding to bias with these more tactful remarks. So it's okay to give yourself permission to be sort of snarky and blunt. You can say something like, the exact day my leave is over, I'll be right back here. So like microaggressions are stressful and they add up. And it's okay to acknowledge that stress as a real experience that you're going through. And if you see someone else reacting in a way that seems like an overreaction, remember that what might look like a minor isolated incident to you could be part of a much broader pattern of microaggressions for them. So wrapping up, yep. So anytime you're confronted with a biased comment addressed at you or addressed at someone else, you have options. You can take control of the situation. So anything from labeling the stereotype, to transferring the work back to the speaker, to just getting pissed off, because that's okay too. Again, we are the Unconscious Bias Project. We give longer workshops. If you're excited about that, we're all volunteer. Follow us on social media. Thanks.
Thanks. Question?
So it was founded by my housemate. So I've been around since the beginning of her thinking about these topics. And I did my grad school in the male-dominated field. I'm a founder now, so that's a very male-dominated space to be in. And actually, founding something has been much more difficult than being a computational biophysicist in terms of the gender issues that I've dealt with. I know that's different for different people, but academia is much more friendly to me than tech and founding has been. So, yeah, there's people from a lot of different backgrounds involved. Fun.
Okay, great. Julie's next, and then I will end off our session.
Cool. Hi, everybody. My name is Julie. I am a data scientist at Twitter. And in my spare time, I was also one of the conference organizers for SciPy 2016. So what is SciPy? The SciPy is 3 things to me. SciPy is a stack. It has a lot of different libraries and packages that help people who are really interested in analytics do their work. It is a community of people who helped to develop that stack. And it's also a conference where people who are part of the community who developed the stack come and talk about their awesome work. So what happens at SciPy conveniently gets recorded and uploaded to YouTube. So if you weren't able to come, you can see all the talks, the tutorials, and some of the birds of feathers. The conference website is scipy2016.scipy.org, and it has like a list of like all the different talks and whatnot. And it was really great. So I highly encourage you all to go to the website and go to the YouTube link and watch all the videos that you can. So this, I'll send this back out to people so they can stuff, because this is mostly just a bunch of links. So there are 2 conference tracks this year. One was high performance computing in Python, which I know very little about. So go to that link. There was a really nice, understandable keynote by Andreas Klockner. It was great. And then the other one was data science. And as a data scientist, I was very excited to learn that we were so focused on it. And so there are 4 kind of big tracks. There's data viz, different techniques and tools for data science. Computational social science was something that was emerging, which was really interesting. And then Project Jupyter, we all know and love. The high-level takeaways were maybe think about Python 3. Data science, like other sciences, should be reproducible, which is not something that I think data scientists always think about. Maybe really start thinking about switching to Python 3. And oftentimes in data science, the questions that you're asking are much more interesting to the data scientist than how to answer the questions. So what tooling do you need? So how can the SciPy community make tools that make data science easier for data scientists? And finally, seriously, this is the last iteration of Project Jupyter that will support Python 2, switch to Python 3. So data viz packages, again, the question is, how do you make data viz easier? And so there was a nice keynote about this, and they had like a nice little Punnett square of like different kinds of data plotting packages. And so they broke them up into imperative versus declarative. I'm sure a lot of us have used matplotlib, and it's kind of a lot. And so they're sort of lighter weight things that you can use, like Seaborn, but that doesn't necessarily have the full functionality. One package that is really interesting is Altair. It's much lighter weight, it's declarative, so it's easier. You just say, I want to plot these things, and it plots it. Great. Hollow Views is another really interesting plotting package. You can easily organize your different data sets, like by color. You can add in legends, you can add interactive elements. It's quite nice. And then Data Shader was really interesting. So like typically if you have over like 100,000 data points, it's basically impossible to visualize them in a meaningful way. You have like overplotting, you have like misrepresentation of what you're actually trying to show. And so this is something that actually handles 100,000 points, which is and over, beyond. I don't actually understand how it works, but it does, and it's great. So data science techniques and tools. So what techniques are available for working with missing data was like a nice talk, and there's basically 4 different ways. I highly recommend that talk. HDBScan is a clustering algorithm. So k-means is a typical clustering algorithm that people use in data science, and it's not so great. But HDBScan is nearly as performant as k-means and does a much better job at finding clusters. CondaForge is another tool that's really interesting. So if you're a data scientist, I highly recommend using Anaconda. It has like all of the SciPy stack that you use on a daily basis. It's a nice way to handle environments. CondaForge helps fill the gaps where Anaconda might not have. Computational social science is a thing that like we talked about a lot, and it's the study of social phenomena using digitized information and computational and statistical methods. And one of the keynotes was Hannah Wallach, and she just gave us an incredible talk. And one of the things that she brought up that I think is really important, and as data scientists and consumers of data, we need to really think about is ethics in data science. So is my training data biased? And is that gonna make a biased model? And so it's something that she mentioned briefly. I have not much time. OkCupid profiles, you can scrape those and find out what words people say if they're drug users, and then you can make a model guessing if people do or not. Finally, Project Jupyter has a bunch of stuff. You should look at these slides. And there's a cool thing at Twitter. Also, Twitter's hiring. If you're one of these and you're looking for a job, come find me or DM me. J.Crew. Thanks.
Great. Question for Julie? Volunteer, yay. Okay. Cool. Okay. So my talk's called Empowering Neighbors in Need with Tech Skills. My story, 4 years ago, I learned to code, and I was only able to do that because I scraped together enough money by hurrying and getting married and asking people to give money instead of gifts, which sounds crazy, and it is. There's a huge opportunity gap, right? If I had to do that in order to get the education I needed. But it tripled my income. It was great. I loved the stability. And so ever since then, I've been really passionate about getting different people to join tech. So I have a Learning to Code resources spreadsheet that has hundreds of things on it. I've organized meetups and workshops like this. And last year I did the I Look Like an Engineer ad campaign, raised $47,000 for that. And so I'm really passionate about this, but the current training things that exist are really expensive, and you have to cover the expensive cost of living. You need a laptop for most workshops. They don't usually reach out to low-income folks, and there's lack of support for parents and other problems, right? So I started doing free workshops at labs in San Francisco, and we've had childcare and lunch, and we've advertised with local organizations rather than online to get a different demographic. We've had a full range of students, from people who didn't know what coding was to people who said, I've always wanted to get a CS degree, but I can't afford it. So we ended up making our flyers say, learn how to make a website, because coding was this weird word. No one knew what it was. And it's been great. People are super smart, and they're breaking down stereotypes of being lazy or not smart, right? These are really resilient people who just need an opportunity. And we've had a lot of great volunteers come help out, and we're always looking for more. And 100% of the people who have attended have said they would love to join again. So it's going really well, and people love it. Several people have said, coding is way easier than I thought it would be. So I started doing all this research because I live near the Tenderloin, and I realized that the income disparity in San Francisco is worse than Rwanda in some parts. No diss against Rwanda, I'm just trying to put it in perspective. I also saw that 59.6% make less than $35,000 a year, which is less than a one-bedroom in San Francisco. There's a lot of problems with displacement. People are frustrated with tech, even though they don't have a great idea of what that is. And there's just a huge opportunity gap. On the other hand, companies are struggling to build up diversity numbers because diverse teams, A, don't get criticized as much, and B, are way more productive and innovative and a whole bunch of other great things. So I started thinking, maybe the tech companies in need of diverse teams and the people in need of jobs can help each other with tech skills. So I am starting a nonprofit, and it provides free tech training and living stipends to low-income women and non-binary adults, and then places them in positions at the sponsoring companies. And they need to be companies that are ready to support diverse teams. So we'll be providing some inclusion training for them. So if you'd like to get involved, let me know. And that's my email address. Questions? Christina. Oh my gosh. The most popular, obviously, is the teaching. People love to come work one-on-one with the students. I am writing grant proposals right now, which I have never done in my life, so I could totally use help with that. Advertising, I'm writing an announcement post so people know that I'm working on this. Editing, open source, so companies can give input, so I need help with that. Seriously, any skill you have, I can put you to work. All right, thank you. Okay, switching modes. Now I'm the host of this event. Thank you, everyone, for coming. Raise your hand if you enjoyed or found at least one thing interesting. Yes, great. So because you loved it so much, you want to help with the next one, right? Seriously, email me and we will do that, okay? Also, I have this whole Google Doc that tells you how to host an event if your company wants to host one. And all you do is you just book it on the calendar and it goes through all the steps. And I can also add you as an organizer or just use your help with social media or whatever. So we need help. Please help us. All right. Any questions before we mingle and then head out the door? Great. Thanks so much for coming.